Download this code from codegive.com, link in the description below. Checking a zone for corrupted entries in bind, a detailed tutorial with BR Consulting docs and code example. This tutorial will guide you through the process of checking a bind zone for corrupted entries. We'll cover various types of corruption, how to identify them, and provide a Python script, inspired by BR Consulting's documented methods, for automated checking. We will focus on general best practices and common error scenarios and build a reusable tool that you can adapt for your specific needs. Why check zones for corruption? DNS zones are the foundation of Internet address resolution. Corruption within a zone can lead to service disruptions, users unable to access websites, email services failing, and other network-related problems. Security vulnerabilities, incorrect records can be exploited by attackers to redirect traffic to malicious servers, leading to phishing attacks or data breaches. Data inconsistencies, incorrect or outdated information can propagate throughout the DNS hierarchy, causing widespread confusion and frustration. Performance degradation, faulty records may cause resolvers to retry queries multiple times, impacting DNS resolution speed. Types of zone corruption. Zone corruption can manifest in several forms. Here are the most common ones. 1. Syntax errors, basic errors in the zone file's structure, such as missing semicolons, incorrect record types, invalid domain names, or malformed IP addresses. These are often detected by the named check zone tool. 2. Duplicate records, multiple records with the same name, type, and TTL, but different data, especially problematic for AAA, MX, and name records. 3. Name conflicts, name records that conflict with other record types for the same domain. A domain cannot have both a name and any other record type, MX, text, etc., except for DNSCI, RSIG, NSEC, and NSEC3 param records. 4. Dangling records, records that point to non-existent hosts or services, example a record pointing to an IP address that no longer exists or an MX record pointing to a mail server that is offline. 5. Circular dependencies, name loops, a chain of name records where each record points to the next, eventually looping back to the starting domain. For example, a.example.com. Name b.example.com, b.example.com. Name c.example.com, c.example.com. Name a.example.com. 6. SPF record issues, incorrectly formatted or overly complex SPF records can cause authentication failures and impact email deliverability. Common issues include invalid mechanisms, example typos in include, IP4, IP6, MX, A. Exceeding the maximum number of DNS lookups, typically 10. Using deprecated mechanisms. Using PTR mechanism, strongly discouraged. 7. SOA record errors, problems with the start of authority, SOA, record, which defines the zone's configuration. Incorrect values for serial number, refresh, retry, expire, or minimum TTL can lead to zone transfer issues. 8. Wildcard issues, wildcards, star.example.com, can sometimes unintentionally override or conflict with specific record types. Tools for checking zone integrity. 1. Named check zone, bind utility, the primary tool for validating the syntax and basic structure of a zone file. 2. Dig, DNS lookup utility used to query DNS servers and examine the records returned. Helpful for checking for duplicate records, dangling records, and name conflicts. 3. ENS lookup, DNS lookup utility similar to dig, another command line tool for querying DNS servers. 4 online DNS checkers * web-based tools that perform various DNS checks, including syntax validation, record consistency checks, and DNS server health monitoring. Examples include DNSViz and MX Toolbox. 5 custom scripts * automated scripts, like the one we'll develop below, can be used to perform more complex checks, such as detecting dangling records or circular name dependencies. BR Consulting's approach, general principles. While specific BR Consulting documentation might vary in detail and specificity, the underlying principles often involve systematic parsing break down the zone file into its constituent parts, records, directives, comments. Rule-based validation apply a set of rules to each record to check for compliance with DNS standards and best practices. Data integrity checks verify the consistency and accuracy of the data within the records. Correlation analysis examine the relationships between different records to identify potential conflicts or dependencies. Reporting provide clear and concise reports of any errors or warnings found in the zone file. A Python script for zone checking, based on BR Consulting principles. This Python script provides a framework for checking a zone file. It incorporates several of the principles mentioned above and can be extended to handle more complex scenarios. Explanation of the script *. 1. Import libraries *dns.zone, dns.name, dns.datatype, dns.resolver, for working with DNS data, resolving names, and regular expressions. 2. Validate _zone _file, zone_file _path, function *. Takes the path to the zone file as input. Initializes errors and warnings lists to store the results of the checks. Loads the zone file using dns.zone.from_file. The check_origin equals false parameter is important. When set to true, default, the script verifies that all domain names within the zone file belong within the zone's origin domain. If you are validating a subdomain file, this might produce many false positives. Iterates through each record in the zone file. Name conflict check checks if a domain has a name record and other record types, other than NS, SOA, DNSKI, RSIG, NSEC, and NSEC3 param. Duplicate record check checks if there are identical records, same name, type, data, and TTL. Record type validation performs specific validation checks based on the record type, AAAA, MX, text. The script includes IPv4/IPv6 address validation and basic MX record host name validation. It also demonstrates how to call a helper function, validate_SPF_record, for more complex text record checks, like SPF. Dangling record check attempts to perform reverse DNS lookups for A and AAAA records. If the reverse lookup fails, it flags the record as a potential dangling record, since there is no PTR record. This is a slow operation because it requires DNS queries. Name loop detection analyzes the name records to detect circular dependencies. This provides basic name loop detection by traversing the name chain. A more robust implementation might use graph theory algorithms. Returns the errors and warnings lists. 3. Validate_SPF_record, SPF_record, function *. A helper function for validating SPF records, text records starting with V equals SPF1. Asterisk includes example checks for the presence of the PTR mechanism and exceeding the limit of include mechanisms. This function should be extended to include more thorough SPF validation rules. For if __name _ equals main _ block asterisk. This is the main entry point of the script. Asterisk sets the zone _file variable to the path of your zone file. Asterisk calls the validate _zone _file function to perform the validation. Asterisk prints any errors and warnings found in the zone file. How to use the script asterisk. 1. Install deanspython asterisk pip install deanspython. 2. Save the code asterisk save the code as a Python file, example zone _checker.py. 3. Replace example.com/db asterisk replace example.com/db with the actual path to your bind zone file. 4. Run the script asterisk python zone _checker.py. Example zone file, example.com/db. Extending the script asterisk. Asterisk more SPF validation asterisk add more rules to the validate _SPF record function to check for other common SPF issues, example exceeding the maximum number of DNS lookups, using deprecated mechanisms. Asterisk dangling record detection asterisk instead of just checking for the absence of a PTR record, try resolving the A/AAA record's IP address to a host name. If the resolution fails or returns a different host name, flag it as a potential dangling record. However, keep in mind that forward confirmed reverse DNS, FCRDNS, is not always guaranteed. Asterisk more complex name loop detection asterisk implement a more sophisticated algorithm for detecting name loops, such as using graph theory techniques. Asterisk integration with monitoring systems asterisk integrate the script with a monitoring system, example Nagios, Zabbix, to automatically check zone files on a regular basis and alert you to any errors. Asterisk support for different zone file formats asterisk extend the script to support other zone file formats, such as zone files stored in databases or other data sources. Asterisk command line arguments asterisk add command line arguments to allow users to specify the zone file path and other options, example enabling/disabling certain checks, specifying the DNS server to use for resolution. Asterisk zone transfers asterisk check the integrity of zone transfers. Asterisk DNSSEC validation asterisk verify the DNSSEC signatures associated with records in the zone, if DNSSEC is enabled. Asterisk reporting asterisk generate more detailed reports of the errors and warnings found in the zone file, including the line number and context of the error. Important considerations asterisk. Asterisk permissions asterisk make sure the script has read access to the zone file. Asterisk DNS resolution asterisk the script uses the system's default DNS resolver. If you want to use a different resolver, you can specify it using the dns.resolver.resolver object. Asterisk performance asterisk the dangling record check can be slow because it requires DNS lookups. Consider caching DNS responses or performing these checks less frequently. You can also parallelize the DNS lookups using threads or asynchronous programming. Asterisk false positives asterisk be aware that the script may produce false positives, especially for dangling record detection. Always manually verify any errors or warnings before taking action. Asterisk security asterisk be careful when running the script in a production environment. Avoid running it with elevated privileges and make sure the script is properly secured. Asterisk BR consulting documentation asterisk always refer to the specific BR consulting documentation for your environment for the most accurate and up-to-date information. By understanding the principles of zone file validation and using tools like named check zone and custom scripts, you can proactively identify and correct zone corruption issues, ensuring the reliability and security of your DNS infrastructure. Remember to test thoroughly and adapt the script to meet your specific needs.